Welcome to the Burns Academy National 5 video for factorizing difference of two squares. So our learning intention is to learn how to factorize an algebraic expression, which is a difference of two squares. To do this, you need to know how to identify square numbers or square terms, and you need to know the roots for those square numbers or terms. Pretty simple. When you factorize two terms which have both been squared, they both, let's underline that, or highlight it. Ooh, for fun, let's just I'm in that kind of mood. We're going to make it a highlighter. So they both have been squared and they are both separated by a minus sign, and it has to be a minus sign, plus won't work. You need to do the following formula. A squared plus b squared is equal to a plus b brackets times the brackets a minus b. A and b are the roots of a squared, so those are the two numbers we multiply together to make a squared are a, and the two numbers we multiply together to make b squared are b and b. They're identical terms. If you don't understand square numbers, you need to go to BBC Bite Size and have a look around. So the first step that we're going to do is to find the roots. And the root of 16 is 4, and the root of x squared is x. The next thing we're going to do is put those roots into two different brackets. And we put them in the same order that they're written in the original expression. So there we go. And then the next third step is we put a plus in one bracket and a minus in the other. It doesn't matter which order you put them in because the brackets are being multiplied. Now, note, there's no equal sign here. So we're not looking for a solution. We are literally just factorizing it. This is as far as we can go, and this is all you have to do. As far as factorizing goes, difference of two squares is probably the easiest one to master. Let's do some practice. So when we have y squared minus m squared, we find our roots. So we've got y and m as our roots, and then we put them into two brackets, a y and an m in each bracket in the same order that the expression has them. Then we can put a plus and a minus into each bracket, and you're done. Simple as that. Don't worry if there's numbers involved, coefficients in front of these terms, because if they're square numbers, it still works. So the square of 25 is 5, the square of n squared is n, the square of 36 is 6, and the square of t squared is t. So I've got my roots, and I can put those into brackets, keeping them in the same order that they are in the expression. And then I just put a plus in one bracket and a minus in the other. And we are done. Simple as that. Don't forget, 1 is itself a square number. 1 times 1 is 1. So the root of 1 is still just 1. Then we have a 3 and we have an h. Those are my roots. It doesn't matter if the letter comes in first term or second term. As long as it's squared, the position is irrelevant. So I put them into brackets, keeping them in the same order. So I have 1 and 3h, 1 and 3h, put a plus in 1 and a minus in. Okay, so that's our answer. Sorry, I had a small interruption. I don't know if I've just repeated myself or not. Moving on. Okay, so in this one, again, we've got coefficients, but we know the root of 144 is 12. We know the root of 81 is 9. And x squared is x and y squared is y. So once again, just keeping them in the same order, we're going to have 12x and 9y in each bracket. I'm writing this really bigly. Oh, goodness me. I don't know why. Plus in one bracket, minus in the other. And that is our factorization. Now, you've got to remember when you are being asked to factorize a problem, you've got to do it in a specific order. And the first thing that we always look at, always, is common factors. That's what we did in the video prior to this one. If you haven't looked at that video, you need to go back now and look at it before you proceed any further. However, if you have looked at the video, we can carry on. So the key to this common factors is finding the highest common factor between the two numbers that we've got. And in this case, it's going to be 8, because 32 is 4 times 8, and 72 is 9 times 8. That's our highest common factor. If we take 8 out of this, we can then put everything that remains. So we're taking that out. We put it in front of the bracket. Everything that remains will be a 4v squared minus 9. Now, I need to look and see if I can do a difference of two squares. 4 is a square number, v is a square number, 9 is a square number, and the word difference just means minus, and we do have a minus sign. I'm just going to put the highlighter on just because I'm in that kind of mood. Maybe I won't because it doesn't seem to be playing ball. Anyway, I have a minus sign right here. So we can write our roots in. So the root of 4 is 2, the root of v squared is v, and the root of 9, square root, is 3. So keeping the 8 out front, I can then put each of those, oops, excuse me, I put the wrong number in there. I can put each of those into a bracket. Remember, it's really important they stay in the same order that they are in the original expression. And I put a plus in one and a minus in the other. And it still doesn't matter which order they're in because those brackets are being multiplied. So we'll try another example. So in this case, oh goodness me, I'm going to see if 5 works. So I'm going to take 5 out, and that will leave me with 100 m squared minus, and 5 goes into 180, 36 times. Those of you who are a little eagle-eyed will notice that the number changed. I had to pause the tape because I had actually put in an incorrect number, so I can only apologize for that. What we have now is we've got two numbers that have roots, and the roots are 10 and 6. We've got two terms with roots, and we have a minus sign, so we have our difference of two squares. So we can just put our 5 in front, and then we'll put a bracket with 10m and 6y twice. We'll do that. And in the one bracket, we will put a plus sign, and the other we'll do a minus, and that is all there is to it. So here's some for you to try. If you're in my class, I'd like you to pause the tape now, do this working in your workbook, and only advance forward if you've completed the work to check what you've done. So let's see how you've done. In the first one, we have x squared minus 25, and the root of x squared is x, the root of 25 is 5, so our answer will be brackets x plus 5 brackets x minus 5. Number 2, we have 36p squared minus 81q squared. The root of 36 is 9, and this, 6, and this root of 81 is 9. So when we put them into brackets, we'll have a 6p minus 9q bracket, and then 6p plus 9q in brackets. The next one, looks like it could be a difference of two squares because we have in fact got a square number here, and we've got a minus sign. But this is not a square number. Not a square number. So what we need to do is go back to basics and look for a common factor. And a common factor that'll work for this is, if I can get it to come up, maybe I can, there we go, 2 brackets d squared minus 9. Once you've taken that common factor out, you can see that we now have got a difference of two squares. We have two square numbers separated by a subtraction sign. So we can then factorize that as 2 brackets d plus 3 brackets d minus 3. And finally, we have 12 x squared minus 27y squared. Again, it looks like it should be a difference of two squares, but it doesn't quite work. Let's look for a common term, and when we common factor, and when we do that, we take 3 out. We end up with 3 brackets 4x squared minus 9y squared, and then we can further factorize that into 3 brackets 2x plus 3y, close brackets, and then brackets 2x minus 3y, close brackets. I hope you found this helpful, and thanks for listening, and if you're in my class, just bring your questions to class with you tomorrow. Thank you very much.